Okay, so good afternoon. Thank you for coming to this session today. So my name is my name is Shunsuke Sasaki, and I'm a technical solutions architect in the APJ architecture automation team. And I'm very happy to be here to give a presentation in Cisco Connect Korea, because I know that Korea is one of the leading country in the 5G services, and we are running a lot from Korea market. So I'm very happy to be here. So today I'd like to talk about the topic in this title, the 5G slicing and automation in cloud native 5G core. And I hope that this session will give you some insights into some 5G business and the new operation of 5G infrastructure and the orchestration, and to both SP customers in here, I believe, and some other enterprise customers as well. Okay. So this is the agenda, and I will cover the 5G network slicing concept and architecture overview. And after that, I will touch the 5G core slicing and orchestration. And I also cover a little bit about 5G transport and the DC slicing overview. But I will not cover the details of the Cisco orchestration product, but I will touch the architecture and overview of our solution. Okay, so this is the agenda again, and so I won't repeat the agenda explanation, but I will touch some PoC report which is done recently in the Japan SP customer about the 5G core slicing. That I hope you find it useful for your planning. Okay, so first let me talk about the slicing in 5G overall. So what's new in 5G? So I'm sure you already hear about what's new in 5G, but some of it is about the new service type, like ultra reliable, low latency, or new type of services like enterprise run and private networks, private radio to the enterprise. But today I'd like to focus on the network slicing, because network slicing is on top of the list, and it's all related to the other topics in the 5G aspects. So, and what is network slicing? So the network slicing is actually the end-to-end partitioning of the network resources and network functions based on the business purposes. So that's the summary from the 3GPP perspective. And it means some applications and or some specific subscribers with special contract have a special treatment or dedicated resources from the 5G network functions or network or get a special network treatment in the SP shared infrastructure. So why SP want to do this? Because with this slicing capability, the service providers might be able to provide new services with the SLA to the enterprise customers, and SP might be able to make a new revenue stream out of it. So that is the motivation for the network slicing. So how can we do slicing? So first, let's see the 3GPP point of view about network slicing. So in this picture, each box here is represents the 5G core network functions like AMF, NRF, SMS, blah blah, and you see 3GPP's idea for slicing is about the provide isolated set of 5G core functions for specific applications here. So for example, let's look at from the bottom. If you have gaming applications on your mobile phone, it will get a dedicated mobile core for get to the internet. Or you might have a video application. It might get a dedicated network core to get to the internet. Or if you have like connected car applications running on the car, it will get a dedicated but partially shared the mobile core to those applications. So this is the pretty much the idea of the 3GPP network slicing. But this is not enough to provide the end-to-end slicing, because that was the only mobile core. So we need to think about the end-to-end view about the slicing. So if to get a slicing, the UE need to be provisioned with slicing information, slice selection policies from the core. It is core's responsibility to provision UE to get a network slicing information. So with this policy given by the mobile core, the applications running on the UE get mapping information between the applications and network selection ID, network slicing ID mappings here. So, but for UE to reach to the the mobile core slice, we need slicing in between. So we also need a RAN radio access network sliced according to the slice ID. Also, of course, we need to have transport network sliced according to that slice ID, so that the applications get a proper and assigned slice to get to the specific services. So let's see another example. Okay, so if there is an application that needs ultra low latency, so if you want to get a low latency, so it's not only talk about the dedicated resources. It needs a location problem. It's the UPF needs to be as close as possible to the UE to get the low latency. Especially if you want ultra low latency. So this is another type of the slicing you need for the network in the end-to-end perspective, right? So one more example is instead of using public radio resources, some enterprise customers might want to use the private radio and to run private applications. And so in this case, this customer needs a dedicated radio, dedicated transport, and a dedicated mobile core to get to their slice. So this kind of the slice is also required in the 5G world. So we need to consider how to configure each domains. Every domain needs to be sliced properly to make end-to-end slicing. So to make this happen, so end-to-end slicing is about end-to-end orchestration. We need to configure each domains from enterprise to the data center or transport. Every domain needs to be sliced properly. But so to do this, we might need something like orchestrator, cross-domain orchestrator here, and it needs to be configure everything, every element in every domain, and it needs to keep track of every changes in every domain. So you may ask, is it really possible? So I believe it is not realistic. So our view is, we have a domain-specific controller, each domain, and it takes care of the domain, the network changes inside that domain. And the cross-domain orchestrator should talk to each domain controller to manage end-to-end slicing perspective. So that is the view we believe we need for the to provide a 5G slicing, end-to-end slicing perspective. Okay, so from here I'll talk about the slicing in each domain, especially in the 5G core mainly, and after that I will talk about the transport and DC slicing a little bit. Okay, so you already might have heard in the yesterday's technical session that in 5G era that we have a cloud native network functions in mobile core. So the reason is, we have a microservice instead of the monolithic, the specific purpose-built applications for the mobile. We now have a cloud-style microservice deployment for the 5G core. So that is one reason for the cloud native, and it also means that the network functions are deployed in the container fashion. So it is also new for the service providers 5G core deployment, and also the communications between the multiple network functions in the mobile core is now web-based. So it also needs we need to think we need to review our way of designing the mobile core networking. So with this in mind, so let's review how the 5G core slice management is done in step by step. So let's assume that you get some order to make a slice in the 5G core for a specific enterprise user. So to make the new slice, so the 5G core management system should initiate the launching the new network functions on the platforms. And here, the CCP means it is a container platform, because as I said, the now 5G functions is in the container format. And the only exception is the UPF is still in the VM format today, but it will be in the container format as well. But anyway, so this type of the dynamic instantiation of resources for specific slice is one of the big change from the previous generation of the mobile core, and it is also a benefit for the 5G core operation as well. So let's get back to the flow. So after the instantiation, so the management system management system have to configure the NSSF and NRF to get those network functions onboarded, and also the newly launched network functions need to be configured with the proper day one configuration, so that the slice specific configuration is injected into the network functions. And next, the mobile core rule, the new functions need to be registered to the NRF, and also the newly launched network functions needs to be monitored by the assurance system. So it also needs to be configure the assurance system here. And after this, this is out of the scope of the mobile core. But after that, as I said, the transport or radio part is also needs to be configured to complete the workflow. And of course, the UE should be provisioned properly to get the proper slice. So this is pretty much the completion of the workflow to get for the UE to get the new slice. So from the 5G core perspective. So right, and UE finally UE connects to new slice. This is the basic workflow for 5G core orchestration for slicing. Right. So those kind of the complex workflow is required to make the 5G core slicing work. So what Cisco is offering to this area. So we have an actually the complete set of the infrastructure and the orchestration system to make this work. So the first, we have an infrastructure. So some of you know that we have an Cisco Vim, which is Cisco's OpenStack platform, and which can be used as an NFVI. And we also have an Mano stack, which is defined in the ETSI standard. We already have an NFVO and a VNF manager to manage the virtual network functions on top of this OpenStack platform. And what's new in 5G is container deployment. And we already have a container platform for mobile core, which is mobile core network functions, which is based on the container platform, and which is called SMI, subscriber microservice infrastructure, which is actually the basic, which is basically a Kubernetes cluster, which can run Cisco's 5G network functions on top of that. And plus, we have a Cisco's extension for easier management of the container platform. And to manage the container functions, we also need a CNF manager, as we did need a VNF manager for the VNF functions. But we already included this CNF manager function into this SMI environment, so that we already included this part. So, and on top of this, sorry, I forgot to insert one additional animation, but on top of this, we have an orchestration system to every workflow I showed in the previous slide work. So the core of the orchestration system is Cisco NSO and the Network Services Orchestrator. And for the assurance part, we have a mix of softwares that is Matrix and the Situation Manager is there. So some of this, I won't go dive into each product here, but you will see the demo booth in the first floor about the NSO and the Situation Manager. So please look at the booth if you are interested. Okay, so regarding this PoC, I'd like to briefly explain I'd like to talk about the PoC recently done in Japan, ISP customer. So the first, let me explain the use case of that customer. The customer basically wants to provide a new service, new enterprise service. So instead of the normal user goes to the default slice, which is not actually a slice. This is a default infrastructure. Instead of that, they want to provide a dedicated mobile core for specific enterprise users, so that the enterprise applications can get preferential treatment on the network and the mobile core. And there are the expectations from the service provider and the end user as well. The benefit they are thinking of for end user is prioritized treatment for the specific applications and the guaranteed performance with SLA based on the contract with the service provider. That is the good for some enterprise users. And for service provider, they are also expecting a new benefit. It is a new 5G revenue stream from the new services using this slicing. And as the nature of the slicing is the isolation of the resources and the network functions, so they are expecting isolation of the trouble or incident as well, and to reduce the downtime or easier and faster deployment of the network functions and services. That's the expectation of service provider. And so the PoC as I said, we need to think about end-to-end slicing, but the PoC was only scoped for the mobile core at this time. But later, we are planning to extend this PoC to the end-to-end. So let me jump into the results. Actually, we used as I shown, we used our Cisco's 5G solution block to do the PoC with customer. And first, we have a successful deployment of the Cisco 5G core infrastructure, which means we deployed the Cisco BIM, CBIM OpenStack, or Cisco SMI for the container platform. And on top of that, we successfully deployed our 5G core network functions like SMF or PCF or UPF. And this was the goal of the PoC, and we successfully created multiple 5G core slices on top of this infrastructure. And we used Cisco NSO to orchestrate the workflow to create those slices. And I won't touch that detail, but the netconf is pretty much the important core of the network orchestration in the 5G core. So the Cisco NSO has a very important role here. And lastly, we have successfully made a test call from the simulated UE to the Cisco 5G core. That was the first call successful in Japan. So that was very good for customer and the Cisco as well. So, okay, so so far I have touched the mobile core slicing, and I'll talk about the transport and the DC slicing a little bit. So about transport, so the question is, so 3GPP, is it defining transport slicing something? So the answer is no. The 3GPP doesn't describe how to implement transport slicing, and actually, in the 3GPP slicing document, the transport network is just described as TN here and in the box, and it says out of scope of 3GPP. So we need to think about how to implement the transport slicing. So let's think about that. Okay, let me jump to the conclusion. So the solution for the transport slicing from Cisco perspective is the segment routing. And I believe that many of you already heard about the segment routing, so I won't explain that. But segment routing is for the transport SLA, because if you remember that the slicing, goal of the slicing is about the providing a SLA to the enterprise users for a new revenue stream. So providing SLA is an important feature required for the transport slicing. So about segment routing, it has a capability for the dynamic path control. So for the SLA, we need granular path control or traffic engineering. So the segment routing allows the SP customers, transport network, to be changed dynamically from the controller. So that is the important aspect of the segment routing. And I mentioned about the SDN controller or orchestration. So from Cisco, we are offering a set of the software that consists of the SDN controller. From this picture, this is the transport network, and it's running segment routing. And this SRPCE path computation element corrects the topology and statistics from the segment routing networks. And this WAY or COE crosswalk optimization engine the visualize the topology and the calculates the best path to the segment routing. And NSO configures the entire network with the segment routing configuration. So this consists of the transport SDN orchestration and to make slice end-to-end from the access core metro to the data center. So this is the transport SDN orchestration, and of course we have an open API at each layer. And so that we can integrate those SDN controller into the customer's OSS system, or as I talk about later, but it's integrated to the cross-domain orchestration. Okay, so how about to the data center? So actually, in data center, it is usually does not care much about SLA, because unlike the transport domain, usually DC domain has much capacity and low latency and very high volume fabric is there. So we don't much care about the path control in this data center domain, but we need to care about the another aspect, because if you consider the 5G core, we have an UPF user plane running on the data center compute, and which is running as a virtual machine, or in future it can be run on the container. So what we need to think about is how we can stitch the slice on the transport side together with the data center side. This is the difficult part, because without this, we need to worry about the translation or stitching from the transport layer to the data center layer here. This is a very complex task. So from Cisco, we are providing a solution, which is that we are extending the segment routing in the transport network into the edge of the data center, and to make a seamless interworking between the segment routing and data center fabric. In Cisco's case, we are reading ACI for the DC fabric, but we have a seamless integration between the segment routing and ACI fabric. This is our offer for the slicing between the transport and DC. And also that to make this work, we also need a cross-domain orchestration between transport domain and the DC domain. So we are positioning NSO to both domains, and we allowed NSO to be controlled from the cross-domain orchestrator. And so this is our vision for the transport and DC orchestration for the slicing. Okay, so this is the last section. I will talk about a little bit about the future vision about the end-to-end slicing orchestration. So as I already showed this picture before, this is our vision for the end-to-end orchestration. We have a per domain, controller to manage the networks inside of that domain, and we have a cross-domain orchestrator that talks to each domain controller to manage end-to-end perspective. So if we break down that into each domain, and we map our Cisco product, those domain controller, it should look like this. So in each domain, we position Cisco NSO for each domain as an orchestrator, and NSO should manage each domain inside a domain. And you know that each domain has a very different technologies inside. So in the transport, we have a segment routing data center. We have a DC fabric like ACI, and a 5G core is totally different from the transport or DC. So it is reasonable for each per domain controller should take care inside each domain. But important thing is we need a cross-domain orchestrator. We are positioning NSO as well for the cross-domain orchestrator. That is because NSO supports this kind of layered architecture through this netconf-yang approach, which is model-driven, and it allows the easier integration with each domains like this. And also, we will have an assurance part as well. And as I said in the previous slide, the situation manager or metrics is for static correction, static alarms, log correction, and analytics to give an SP operators visibility and assurance features. So this is pretty much the vision from Cisco. So actually nobody in the world is operating like this right now, but it is a journey. So I think this I hope this we are this gives an insight into the overall architecture for the end-to-end slicing or cross-domain orchestration. Okay, so in summary, as you see, the network slicing in 5G spans across the multiple network domains like transport, radio, and I didn't talk about radio much, but it also have to talk to the radio network as well, and so it needs an end-to-end orchestration. So, and I talked much about the 5G core, and it is built on the cloud-native technologies. So the slicing in 5G core needs the lifecycle management or the automation of the cloud-native functions, which is basically container functions and deployments. And the transport and the data center has each domain has its best technology for slicing. So the slicing in both domains must be done in orchestrated way. So that we need to think about the stitching between those domains. And as you know, the Cisco has an offer about that, the extending the segment routing domain into the Cisco ACI domain. And importantly, the service provider customer and Cisco has started working on the several PoC activities in the 5G core slicing or end-to-end slicing. So we are defining our orchestration architecture together. So I hope it would be great if we could help the Corea SP customers to make this journey toward the end-to-end orchestration together with Cisco. Okay, that's pretty much it. So thank you very much for the attention.